Are you able to open the exercise 4 script? So the basic naive method, as sir suggested, don't go in the starting itself GE. You just look into your t-test comparison, see the standard error and t statistics, and then apply the GE and see the difference. Okay, so for that only we are given t-test and the GE code also. So compare the results of the t-test and GE for the cholesterol data. Cholesterol data is the dependent variable and age, gender is the independent variable. Smoking status. There are two packages used to import your SPSS data set. One is regularly used foreign, library of foreign is used to import your SPSS data sheet. And one more library is Hammond. This is also will helps to read or write the SPSS data sheet. So both packages will helps to open the SPSS file and write it also. Okay. So how to import your data? Please import your data using the file import function. Import the file. Here file import dataset SPSS. Using this method, import your data sheet. So I'm importing my SPSS data. Here it takes Heaven library itself. So that's why read underscore SAV. If it is a foreign library of foreign means read.spss. Instead of underscore, you have to give read.spss. Okay. So import the data sheet. Now copy this path and paste it in your script itself. So in the future also you can use the same code. Okay. Now we have to see the data sheet, right? Instead of seeing all the data set, you just see the first 6 observation. For that, put head of cholesterol. Just run it and see. The first 6 observation, it will provide it in the result view. So we are on the same page, right? Are you able to run data sheet? Everyone got the data, right? Next, you are going to compare the cholesterol between the sex, male and female, and here smoking, yes or no. So run these 2 code and see. Before that, before running this, I want you to type this thing, str of data. Data means your name, cholesterol underscore long. It will describe what is your data set. ID is number 1122. It will start like this. And base fit. What is the base fit? It's 2.15 like that it's given. So that value, how it starts and how it's end. Gender SX means 1, 2. So it will describe how your what are the things your data set as. This str string of the string of data set will provide the description of your data, whatever inside your sheet. Okay. Now run the t-test and see. So confidence interval, mean group of 1 and 2, and p-value is significant. So we are getting significant p-value. Similarly, run for the next thing. Here t is -5, here -2, and by smoking status, the mean value for both the group. Yes. So now we are going to run the GE for linear. The library is GE pack. Decimals. Zero point zero. See here 0.02 for you. Two different thing. 0 to only. For the first one, sir, it's same. Maybe I fixed in, I'm regularly using the R, I fixed the decimal point in the previous sec, means it will come automatically. If not fixed means it will show. Okay. So for running the GE, you need a GEE pack. So if you're not installed GEE pack, remove those asterisk symbol, run it. Before running it, you just try run the library function to check the GEE pack is available or not. Run library of GEE pack. Is it available or not? GEE pack, library of GEE. Run library of GEE. Is it available? So then we are defining the cholesterol dollar. Here we are not attaching our data set. That's why we are giving cholesterol dollar time, cholesterol dollar sex, cholesterol dollar long dollar smoke. If we attach means no need to give this term, just time and what are the variable we have mentioned, just give that name itself. Okay. Numeric factor. Yeah. In why we are giving like this means in if you are importing the data from Excel or CSV, it will consider as it is. But in SPSS, we will give value labels in SPSS. 1 means baseline, 2 means 0, third month, 3 means 6th month. Like that, we will provide the value labels for the coding. Gender, F means 1. 2 means male female will give 1 and 2 and we will provide the labels also. In that situation, if you are importing data from SPSS, this will take female male as a factor. It won't take it as a 1 or 2. That we have one practical example also, that time I will explain it very clearly. So for that we are defining time is as dot numeric and gender smoking status is as dot factor and sex is as dot factor. Okay. So run along with me. Now see the p-value. .011. What is our previous p-value? Less than 0.001. Less than 0.001 because it's minus 0 E0, right? Something. This one is p-value. For gender, 0.011 asterisk. And estimate 0.2622 and standard error is 0.105. See the evolved statistic T statistics 6.5. What is there? It's minus 5 something, right? Or t-test value. I'm asking, what is the result? Just compare this GE result with your t-test. Here it's 6.5. And the p-values, adjusted p-values. Here, what is the correlation structure we have given? This is a standard one. We will provide like a similar time interval. We will give exchangeable correlation structure. As Sir said, unequally or equally spaced means AR1 because over a time the correlation will decrease. So that situation we have to use AR1 and same independence full only. Yeah. For that, what you have to do to understand this? What are the things you need to give? GLM means no. To know what are the things we need to give input means how to search help. Question mark GEPAC colon this GEEGLM. Okay. Well. See. Unstructured, user defined, independence. Like independent. Okay. So 1 unit increase in your thing, how much unit the increased for the 2 means here male, female, I think here female. So female group has a higher cholesterol level.
Wait. The purpose of this exercise is to show you that if you don't interact it with the gender, you are doing simply the t-test. Do you understand this? Why are we doing t-test? To see what is the difference. And we are doing unadjusted GE to compare the results. So on the GE, it tells you there is what is a change between male and female is 0.26 units. Just go to the t-test for gender. Already that this thing is there. Yeah, how much is the difference? 0.26, 0.36 and
Point
0.362, the difference is 0.26. So exactly same. So this is not known to many people. They think they have used G analysis by putting that gender variable in the model. In fact, they are doing t-test. Unless you interact it with the gender variable, with the time variable, you are not doing the GE. Remember, instead of just gender, you take intervention. If you don't interact it with the time variable, and if you do just intervention alone in the model, simply you are doing t-test. Do you understand? When you go back, you have to teach everybody that. Unless it is interacted with the time, the GE is not done. To show you that the difference between the two means are your regression coefficient. So actually the t-test is basically a regression test, regression analysis. Do any t-test, take that variable and do the regression analysis, you'll get the same difference as a regression coefficient. Difference between the two means regression coefficient. That is what we are doing. So what it does is when you have repeated measures 1, 2, 3, 4, 5, 6, it takes the middle value, mean values of the observations and compares it with the t-test. That is all. So totally wrong if you don't interact it with the gender or intervention. Therefore, you don't claim that G unless it is done. Is that correct?
Yes, sir.
Similarly for the
similarly for the smoking, you run.
Now you do the G. Basically by interacting with the
That only sir is telling. See, time we are not mentioning it anywhere. Simple t-test and yes. So previously we have provided t-test and simple G with gender alone. Okay, we are not interacting with the time. So regression and t-test is equal only. There is no difference. But you need to incorporate with the time. So morning sir written one code, right? Beta 1 constant plus beta 1 intervention plus time. Separate models we have given for the main effects, but the interaction effects only will provide the over a period between these gender there is any significant difference or not. So this is our correct model. You need to give time into gender. Cholesterol. Okay.
what is the output? What is the time alone?
And it says, what is the time of the months?
It's on months, I think so.
Yeah, it's called the month.
Months.
If it is in months, one month change in your next variable corresponding change in the first variable.
After adjusting for gender and
Yeah, yes.
and the fraction.
Yeah, usually, yeah, that is correct. If I wanted to know, this is how much is a change after adjusting for gender and the time factor together, or gender and that is all gender only. What I would do is, if I know the command for regression, I'll just run simply the time and the cholesterol values. It will tell you what is 1 unit change. I do the same thing with this model and compare it with this model and say how much is a change. Do you understand? So you need to have simple regression code, linear model, whatever the code is there. Just run it and see. That is easy. But minimum I wanted you to do before you go to this analysis, do the graphs. Morning I do the graph. So I did the graph morning. So you just see that one. It will give you some idea it's going to be different or not. Then you see the run the regression analysis. This is the GU code and compare. So when you write your manuscript, people like to see the graph. Fortunately, if you do a good graphs R code, you'll have better graphs. And then underneath you give this GE analysis. Yeah, this is the see here. So who is having higher values? Females are having higher values. Over time, the trend is same only. Okay. But there is the change. If you compute the change over a period of time, it is significant, highly significant in the model. Do you have any questions? This has to be done first to see, okay, this analysis is going to give me a good result or not. Capture this and put it in your document. So you keep the code and run and make sure that you are able to do it. And you need to save the long format also. Morning she said a write command to save the data. So now you need long data, just read it and do the analysis.
How to save this? We are writing this much. That to save, how to save that?
This output you can save, isn't it?
You can save or copy it
yeah.
and paste it in a Word document also.
We have done this much analysis from morning. So
Yeah.
I want, okay, I'm trying to then see to the next thing.
You save it, the folder wherever you want to see, wherever the data, everything you stored, save it in the particular folder itself. And always if I made any changes, like here means see the save icon will pop up. So you have to save it there itself. Otherwise, file, save as, create one folder, path and save it there.
Any questions? Yes. It is same. This is it is both the interpretations are same. Only thing is it gives you the correct interpretation, like 1 unit change in a time variable. Say for example, I said 6 months and 9 months and 12 months. So if I put the data as 9 and 12 instead of 7 and 6, 7, 8, if you put that and interpret it like 1 month change, then interpretation that is wrong. Because your last two values are 7 and 8. But if you have changed as 9 and 12, that is a correct way of saying it's 1 month change in your time variable. What is the corresponding change?
Okay, sir. In real life, most of the situation, what we have is we'll have, let's say in first month, follow will be done, then in 2 months or 3 months, then after 1 year. So shouldn't we use G in that situation?
You can use, so long you code it like that. 1, 2,
and 12.
And 12.
Okay, yes, sir.
See, maybe you did not get what I said for ANOVA for repeated measures and GE analysis. I'm not sure whether ANOVA for repeated measures will have to deal with unequal spacing of data. Like what you said, if a child comes in the first month, second month, and 12th month, whereas this comfortably you can analyze it using GE. Another child comes at 6 months and 7 months and so on and so forth. Time is a variable. So it is as the advantage of organizing it in the long format is you can have missing values, you can have unequal time intervals and so on and so forth. It takes the average of it. And it says 1 unit change. So if all observations are measured at equal time point, up to 6 readings, then you say 1 unit change in your time, whatever month or year or whatever, then that is the interpretation. If there's an unequal number of interval, then it is a months or weeks, it is easy to do this. If you make it as 7 and 8 in the 9th month and 12th month, that is wrong. And say 1 unit change.
Suppose that is the case, how to interpret? Suppose as she said, we have assessed as 1 month, 3rd month and 12th month.
Yeah.
So how do we interpret? Like
It is like 1 month change only.
1 month change only.
Yeah, 1 month change only. If you make it as 1, 2, 3, then if you make a interpretation like 1 unit change, that is not correct. If you say 1, 2, and 12, then you should use the word 1 unit change in your time. That is a month. What is the corresponding change?
Okay, it actually the coding what we make the difference. So the coding should be 1, 2, 3. 1, 3, 12.
Yeah.
It should not be 1, 2, 3.
You make it flexible. If you say your subjects are going to come for unequal number of time intervals, just deal with that as he came at 9th month, he came at 7th month, and so on. Just run it like that time. Okay, but in clinical trials, it is a protocol. So every subject has to be followed up every month. Then it is 1, 2, 3, 4, 5. You understand? Just a very simple 1 unit change. Not clear.
Actually, if it, I'm not talking about those who didn't turn up at 6th and 7th month, they only turn up at 12th. If everybody was measured only at the 4th month, 3rd month, and the 12th month.
It is use 1, 2, 12. 1, 3, 12. Yeah, just one value is 1, 3, and 12 as a time.
Time, okay.
Sir, generally this time variable we will consider it as a factor variable here. So even we use 1, 3, 12 or 1, 2, 3.
It's not numeric. Ask that numeric. What she said was, sometime in SPSS, you would have made this as factor variable. The moment you give label or whatever, it becomes factor variable. When it comes here as factor, she convert that as that numeric.
Okay, fine.
The factor becomes numeric. It should be numeric. Yeah. Yes. Where significant it is. Which one? No. That is why you should not worry about sex here, gender variable. The gender variable question is gender variable is significant or not. It has to be connected with the time point. Therefore, the following one, gender into time has to be taken.
Only.
Don't try to interpret gender alone here. Yeah. T-test. Here, if the profile, over a period of time, if say over a period of time, there is a significant increase in males, females as compared to males. If you use over a period of time, then it is the GE. Yeah, yes. Please, let me try to tell you this. We do a lot of observational studies. You have to clearly define what is your confounding variable. 3 or 4 confounding variables. Regression is done to adjust for confounding. So you keep it separately. Don't interact it. The moment you interact it, a lot of confusion. It takes time to converge and so on. So sometimes you will not get the convergence. So of the many variables, you'll have 1 or 2 important variables which are hypothesized. You are interested in addressing. So then after adjusting for the covariates, those variables, you need to look at this smoking or whatever. Is that okay? Okay.
Similarly, run for the smoking status and see what the interaction term is showing. Is it significant or not? You just check.